All right, so section 7.4 is all about the properties of logarithms. Because yesterday we looked at just a single logarithm, right? We could kind of think through it and, figure out how to solve them. Not all of them are nice and pretty like that. So we're going to have some equations where we have to use logarithms so that we can solve for, the exponents, and they get obviously more and more complicated. So we need to learn the properties first. Once we get the properties down, then we can move into solving the harder ones and actually apply those properties. Okay? So we are going to learn how we can kind of pull them apart and how we can kind of push them back together to kind of make them work for what we want. So there's a product property. To me, I always think about log properties like exponent properties. If you were multiplying two things with exponents, what would you do with your exponents? In other words, if I had x squared times x to the fourth, what would you tell me that is? X to the sixth. It's a multiplication problem, but you added your exponents. Same kind of idea when you're talking about logarithms. Log base a, it's just whatever the base is, of u times v. We can split that so that there's a log base a of u plus log base a of v. So I can take multiplication and split it apart and put a log on every single piece that's being multiplied. So this is called expanding. If I'm going to go from something pushed together like this and I spread it out to make more and more logs on everything, that's expanding it. We can also work it backwards, where if I had this, I could bring it back together and I can bring it back to a single log with changing those back to multiplying. That makes sense? So kind of those exponent properties kind of play into this as well. Quotient property. So just like if I had x to the sixth over x cubed, what did you do with those? What is this? The x to the third, you subtract, right? So same idea here. If it's a division, for me to expand this into putting a log into everything, you would separate division with a subtraction. But that same log attaches to every single piece. And then the power property. So if you had x to the third to the fourth, what's that? I can stand here all day, guys. You can answer my question. If you don't know how to do this, and I don't know how you made it this far in this class. What's x to the third to the fourth? X to the 12th. Good. So when you were raising it to an exponent, you multiplied. Same idea here. When I have an exponent, that exponent gets thrown out in front, and now it's multiplied by that entire log. So anytime you have an exponent, they get thrown out in front, and it's, in essence, it's like it's being multiplied by whatever answer you would get right there. Okay? So those exponents, which you would multiply, exponent comes out multiplying. If it was division, you'd normally subtract. Division, you separate them by subtraction. If it was multiplication, you added them. If it's multiplication, you separate by adding. So those same kind of properties follow all the way through. So what is the expression written as a single logarithm? So right now it is expanded, right? It's got more than one log. If I wanted you to rewrite that condensed and simplified. So whatever the log base, whatever, it's going to stay the same. Yeah. Good. And I actually don't need the parentheses. Okay. So it would be 32. Since it's subtraction, that means I would divide, and it was a 2. Can I simplify 32 over 2? Mm-hmm. So that would become log base 4 of 16. What's log base 4 of 16? What'd you say? It's 2. Because remember, this is asking you 4 to what power is 16? 4 squared is 16. So the answer to this one is just 2. But if I looked at the original problem, it's not as easy to look at that one. Like 4 to what power is 32? It's not pretty. I can't do that. But by using the properties to condense them down, I was able to actually simplify the entire thing. All right, number 2. So again, I'm going to make sure, since I'm condensing to a single log, it's going to be log base 2. Now let's kind of think through our properties. So if I have a number out in front, where did that come from? What property had me put something out in front? Where did that come from? Which one of these properties did something come out in front? The power one. That number that came out in front was an exponent. So if I'm going back the other way, this now is an exponent on whatever was over there. So that's now x to the 6. And then what's a plus mean? Does that mean I'm multiplying or am I dividing? Yes, a plus normally means I'm adding, but it comes from what with my log properties? Multiply. That means x to the 6 is being multiplied. There's a number out in front. Where does that come from? It's an exponent of y squared. Or I'm sorry, y to the 5th. Would I need the dot in between? No. Could I put them in parentheses if I wanted to? Yeah, but I don't have to. So log base 2 of x to the 6, y to the 5th. Can I go further? Can I multiply the x and y together? No. Do I know 2 to what power equals x to the 6, y to the 5th? No, that's kind of weird, right? So I can't actually take that one any further. It is condensed down to 1 log, and that was what it asked me to do. I can't actually simplify any further. This one I was able to kind of keep going and get an actual nice, pretty answer. All right, log base 4 of 5x plus log base 4 of 3x. Now everything I give you, just to make sure we're clear, you will have the same base numbers, okay? Because if they're not the same base, you can't actually condense them. But I'll give you everything that's the same. So it's going to come back as log base 4. And then I have no number in front, so there's no exponent. So I have a 5x. The plus sign means I'm going to be doing what? Multiplying. And I'm multiplying, again, no number in front, so 3x. Would you stop there, or could you go one step further? One step further, because 5x times 3x is 15x squared. And then once I've simplified that as far, I always ask myself, loopy swoopy, right? 4 to what power equals 15x squared? No. If there's a variable left in there, you're never going to be able to loopy swoopy that any further, because it's got a variable in it. All right, number 4. Right away I see I have a number in front. What's that mean? It's an exponent. Now it is only an exponent on whatever's with that log, right? It's like that's its own separate little piece. So that's an exponent here. So I know it's log base 4. I'm just going to write log once because I'm condensing it down to 1 log. So that comes back up as 6 squared. I'll take this kind of one step at a time for you. And then minus, which means I'm going to divide. Good. No number in front. I just have a 9. Go further. Yep. What's 6 squared? So I have log base 4, 36 over 9. Okay, so that is log base 4 of 4. Can I loopy swoopy? 4 to what power equals 4? 1. So the answer to that one is just 1. Every time there's a number, will I always be able to loopy swoopy that and get a nice answer? No. If that had been log base 4 of 3, 4 to what power equals 3? I don't know. That's not a nice one. Yeah, so no, if it's like going to be a decimal nasty answer, we just leave it. But like that one, 4 to what power is 4? Hopefully you recognize that's just 1. All right, let's try to go the other direction. Okay, use the properties of logs to rewrite and simplify the logarithmic expressions. So I need to try to do something else with this. We're going to try to expand these. So I'm going to put my log with every single piece and kind of use all my properties. So I have log base 3. The first piece I have is 9 squared. What am I going to do with this squared? It's in the front. Good. That comes out in front. So it's 2 log base 3 of 9. Since I have multiplication, what comes down here? Plus. Very good. I have an exponent again. Good. That goes in front. Log base 3 of 2. And you're like, why on earth did I do that? Can you simplify that? Do any of these loopy swoopy? 3 to what power equals 9? 2. Yeah, we got to make sure we're thinking in terms of exponents, not just multiplying. 3 squared is 9. So this part right here is literally just a 2. There's a 2 in front of it. So that becomes 4 plus, can I do this one? 3 to what power equals 2? That one's not so pretty, right? So that one's going to stay. So 4 log base 3 of 2. Now be careful, don't add the 2 4s, because that 1 4 is being multiplied. That'd be like you adding 4 plus 4x, right? They're not like terms. All right, number 6. Go ahead and expand this one. So I have log base 2. And again, every piece that you have is another time you write the word log. So how many times will I write the word log on number 6? A ton? I heard 3 times. I heard once. Twice. That's the right answer. I'm going to write it twice. Because how many things do you have? I have a 16 and I have an x squared. How many things are being multiplied, divided, whatever, together? Yeah, so that's one of the things I'll probably ask you on every question. How many times will I write log? I'm going to write it twice because I have 2 different parts. All right, so I have log base 2 of 16. That's being multiplied by x cubed. So multiply means I'm going to write plus. And there's an exponent on it. It goes in front. So good. So 3 log base 2 of x. Once you expand, you always want to go back and be like, can I simplify anything? Log base 2 of 16. 2 to what power equals 16? 4. That one's 4. Right, that's what that equals. And then that one has an x on it, so I can't do anything with that. So plus 3 log base 2 of x. So do you see why we're spending an entire day or two just on properties before we move into solving? Properties they're okay once you kind of get the hang of them, but they're a little tricky at first. All right, so number 7. How many times will I write the word log? Twice. I'm going to write it on the 6, and I'm going to write it on the 200. Now, 6 over 200, does that bother anybody else but me? It should bother you, because what's wrong with it? That's not simplified. We know that we simplify everything. So instead of 6 over 200, I should write 3 over 100. Yeah, let's always make sure they're simplified. All right, so writing this one out, we're going to have log. What's the base? 10. Good. If it's not written, it's that unspoken 10. Log base 10 of 3. Then there's a division. So subtract log base 10 of 100. So that's using my properties. And then what we used yesterday, what we learned, do any of those simplify? Yeah, because this is asking 10 to what power equals 100? That's 2. So log base 10 of 3 minus 2. You do not have to write the 10. If you don't write a base number, we always assume it's a 10. Can I do 3 minus 2 and write 1? No, big difference, because this is asking 10 to what power is 3, and then whatever that answer is, you'd subtract 2. So that's very different. All right, number 8. How many times will you write the word log? Twice. You have 2 parts to that one. All right, so we're going to have log base 7 of 1. And then what? Minus, because it's division. good. Do either of those simplify? 7 to what power equals 1? Jasiri? Yeah. 7 to 0 power equals 1. So this is 0. Does 7 to some nice pretty power actually make 147? 7. Yeah, I gotta think exponents. I know it's so hard to trick our brain to thinking that way. So try it. What's 7 squared? 7 cubed? Do I? No. So 0 minus log base 7 of 147. Do I need the 0? No, I could just write negative log base 7 of 147. I could write it that way. It's fine. How are we feeling so far? I think when we started, I think a lot of you were like, I feel like we're a little better. Expand each log expression. So we're still working on expanding. So number 9, how many times will you write the word log? I heard 2, I heard 3. It's 3. Because I have a 5, I have an x cubed, and I have a y. I have 3 separate pieces. So we're going to have log base 4 of 5. And they're being multiplied, so I'm going to write plus. Exponent goes in front. So 3 log base 4 of x plus log base 4 of y. Once you expand, you always want to go back. Can you simplify any of them? Obviously, if it has an x or a y or a variable, I don't have to worry about those. But does 4 to some power equal 5? Not a pretty one. Nope, so we would be done here. All right, go ahead and try number 10 on your own. All right, how many times did you write the word log? 3 times. What's the base number? It would be 10. So I can write log of 3 plus 2 log of x plus log of y. That's what it should look like. And none of them actually simplify because the base number is a 10. So it's asking 10 to what power equals 3. It's not a nice one. And the other ones have variables. Excuse me. So I can't go any further. Questions so far? Okay, still working on expanding. Number 11, how many times will you write the word log? It's 4. I have a 4, I have an x, I have a 3, and I have a y. Yeah, so there's a lot of pieces to this one. All right, and something else kind of happens here we need to be careful of. All right, so starting out, we have log of 4, and then what symbol? Plus log of x, and then what symbol? Minus log of 3. What symbol goes next? Like, wait a minute. You could do this 2 different ways, okay? First way, Carrie said, don't I need parentheses? That fraction bar is my minus, but then I have a piece that's connected underneath. So it'd be log of 3 plus log of y. So you could write it that way, but you have to have parentheses. What's the other way you could write it? I mean, you could not and get them wrong, but you know, they would both be minus. So log of 4 plus log of x minus log of 3 minus log of y. So either one, I don't care which way. Either way is fine. It's whatever you're comfortable with. Now, if you're somebody who, like Carrie right away recognized, don't I need parentheses on that? So she'll probably choose the parenthesis option, would be my guess. Me personally, I would write the parentheses. But some of you might just want to look at, hey, if it's on the bottom, it's a minus, okay? The minus puts it on the bottom. So if you want to do that every time, that's okay with me too. They mean the same thing, so whatever you're more comfortable with. How what? I would take either answer. It don't matter. I could go either way. Number 12, how many times will you write the word log? Twice. I have an x to the 4th, and I have a 729. So I have 2 of them. So log base 9 of x, where does that 4 go? Yeah, that's going to go out in front. So 4 log base 9 of x. And then what symbol? Minus log base 9 of 729. Does that one simplify? Does 9 to some power equal 729? 3. So 4 log base 9 of x minus 3. Ta-da! Come on, a little fun? Little? I enjoy these. If you have nothing else to do. And if you were grounded. Go ahead and do 13 on your own. All right, so you should have written the word log 2 times. So you would have log base 3 of 9. These are being multiplied, so it would be a plus. Exponent goes out in front, so 5 log of x, okay? And then do either of those simplify? Yeah, the first one's asking 3 to what power is 9? And that's 2. So 2 plus 5 log of x. Now, walking around, I noticed a couple things. I think right here and now you guys are doing okay, but if I give you, like on a test, and you're doing like a whole test where you're writing the word log all the time, some of you are going to confuse yourself with your own handwriting. Here's what I saw from some of you. Oh, I did. Thank you. Thank you. I'll try to write this how I saw some of you write it. What does that look like? Yeah, that looks like 2 plus 510 g subscript 3 x. And I see, now if you wrote final answer like that, no, that's fine. I understand what you were showing me. But what happens is people go here and then they're like, we're solving. And then they like move on to the next step and suddenly they've made that 510. Like, you know what I mean? Like they're just, your own handwriting gets you. So have you noticed how I write the word log every single time? I do a cursive L. Because a lot of you are just doing the like regular L and it looks like a 1. So that's why if you ever wonder, why do I do that? That's why. It's because that can get very confusing. All right. Expand each log expression. There is a radical on there. Can we write radicals as exponents? Probably. That's the last chapter we did. Yes, we can. Thank you, Jonathan. The square root of 3x, we just did a chapter on this. That's 3x to the 1/2. Because if I have exponents, when I'm doing my properties, where do the exponents go? They go out in front. So it's okay then. If I have it like that, then if you have radicals, switch them to exponents, and now we can move exponents out in front. So how many times will you write the word log? 3 times. So somebody talk me through what they think it is. Carrie? Very nice. Very nice. What part do I think that she was probably going to forget? The half. There's half on both of these. because that exponent goes on both of those. So we need to make sure that gets attached to both. Otherwise, we would only assume it's the square root of 3, not the square root also of the x. Okay? So if you have more than one thing underneath that radical, they all need that part attached to them. All right, just looking, do any of these simplify? Because my base number is what? It's 10. 10 to some power equal 3. Now it's an x. 10 to some power equals 7. No. So I'm done there. All right, go ahead and do 15. All right, guys, on 15, how many times did you write the word log? 2. You should write it 2 times. Anytime I see a radical, you should automatically think I need to rewrite that. That's 2 and then x to the 1/2 because that is a square root. Remember, roots grow underground. It's the bottom number. All right, so rewriting this, we're going to have log base 5 of 2. These are being multiplied, so it's plus. I have an exponent that goes out in front, so 1/2 log base 5 of x. Did you do it right or no? So anytime you have a radical, you want to rewrite that radical with an exponent. That way you can throw that out in front. 5 to some power equal 2. Nope, and that one has an x, so I'm done. All right, number 16. 5 times the cubed root of x squared. So when you see a radical, rewrite it as an exponent. So this would be rewritten as what? Very good, to the 2/3. Roots grow underground, so that's the bottom number. It's obnoxious when I say it all the time, but you'll remember it that way. All right, how many times do you write the word log? Twice. I have a 5 and I have the x. So I have log base 3 of 5. They're being multiplied, so plus. Exponent goes out in front, so 2/3 log base 3 of x. 3 to some power equal 5? No. So I'm done. All right, talk to me, guys. Some of you are making some faces, but I can't tell if you're just processing slowly or just totally lost. You don't get it? What part don't you get? Where did my 2/3 fraction come from? It was last chapter when we practiced going from radical form to exponential. And you can flip them back and forth. Right, but I'm just telling you, you've learned this. Okay, so real quick, just kind of backtracking a little bit here, guys. So if you had 7, then the cubed root of y to the 7th, like that. So do they both get a fraction for an exponent or only one of them? Just one of them, right? The 7's still there, 7. And then that would be y to the 7/3. The root number always is the bottom one of the fraction. Okay? If I had, the 5th root of 7x squared. Since they're both underneath there, that would be, I'd probably write this separately. It'd be 7 to the 1/5 and x to the 2/5. Does that make sense? Since they're both under the 5th root, their denominator number both is the 5. It shows that they both go to the 5th root. Better? Yes? Okay. Other questions? Make sure you're asking, guys, because seriously, if you don't get it, somebody probably else doesn't get it either. Okay. All right, let's go back to condensing again. All right, we've expanded, we've condensed, we're going back to condensing now. So if I'm condensing, how many times will I write the word log? Once. I'm condensing that back down to 1. So I know I'm going to have log. So I'll write it once. And now I just got to figure out what to do with my numbers. So the half in front goes where? It goes on this x as an exponent. That's to the half. Well, what's the half mean? That's the square root of x. And then I have a plus sign, which means I am multiplying. The 3 goes back as an exponent here. Do I need to multiply that out? No. So that's x plus 1 to the 3rd. No. Don't ever multiply that whole thing out. Just don't. It gets ugly and it's not necessary. Questions on that one? All right, 18. Condensing. If I'm condensing, I'm writing log how many times? Once. Once. So I'm going to write log once, and then I'm going to figure out the numbers. Number out in front means it is an exponent, only onto whatever it's next to. So that's going to be x plus 2 squared. What's the minus do? I'm dividing. And I'm dividing by just x. Since there's variables in there, I don't have to worry about loopy swoopy to simplify. I can't cancel those x's, can I? No, that one's held in a parenthesis with an exponent and a plus side. It's held all kinds of ways. Oh, brackets. Those are fun. Some more powerful parentheses. Do you know what the next ones are? Yeah, like the little curvy ones? I always call them like curly brackets, but they're called braces, in case you're wondering. They're called braces. So what does that mean about this 1/3? It goes to everything. Because it's got that bracket, it's saying everything here gets this. So let's go ahead and do that. So I know that's going to get a 1/3, and this is going to get the 1/3. They both get it. You could. I'm just trying to make sure we don't forget it goes to everything. All right, so then we have, I'm going to have log base 2, right? I'm only going to write it once when I condense. So what's the first thing I'm going to write? What is this going to become? The cubed root of x. And the plus sign means I am multiplying. And I am multiplying by, where does the x plus 1 go? Underneath there, because it also has a cube, right? The 1/3, so it's cubed root, x plus 1. So much nicer when you condense that back together. It's not as ugly. Tomorrow we are going to start talking about natural logarithms. Because, you know, regular logarithms aren't enough, right? There's natural logarithms. That's another button on your calculator. You see an LN button on your calculator. We're going to talk about those tomorrow.